The next one was asked about was number 49 in section 8.2, which is like this. And it has limits of integration from 2 over radical 3 up to 2. But I don't really care about the plugging in part. That part's kind of sticky, etc. But for the purposes of this section, what I'm interested in is you being able to do the integration by parts. So normally I would say that you make T into your U, and then you integrate it and it goes away fast. But in this particular case, it reverses on that, which is the tricky aspect of this. So instead I make U be inverse secant of T, and I make dV be T dt. V is then T squared over 2, and du dt is, and for inverse secant, we have a formula before that says this, and it is a x squared minus 1 down here, so it's t squared minus 1 in the denominator. So basically that is what, as we go uv minus the integral v du, that'll be du. Multiply through by dt, and you'll have, that'll be du. So what I then have is uv, u times v, that's t squared over 2 inverse secant of t, minus the integral of v, which is the t squared over 2, du, so I've got a dt, in the bottom I've got a t, and a square root t squared minus 1. One of the t's there cancels one of the t's there. And that's important from the perspective of being able to pursue this integral, because now if I let, and I'm not going to use u again because we've already used u, but if I say I let w be t squared minus 1, dw dt would be 2t, meaning dt would be dw over 2t. And if I make that substitution in here, this part of the integral, I've got a 1/2 already, I've got a t, that is w, so I'm just going to say square root of w on the bottom, and dt is dw over 2t. One of the t's cancels, the other two, the 2 comes out here, I've got 1/4, and now what I have in the integral is w to the minus 1/2 dw, and for that I raise the power by 1, which is to the 1/2, divide by 1/2, which is the same as multiplying by 2, and if I go back to what w was t squared minus 1, so it becomes this. That's the second half, so that minus that, and that's the integral. And then the answer that they gave in the book, then they went ahead and plugged in 2 in here, which gets kind of tricky with the inverse secants and square roots and everything, but they plugged in the 2 and the 2 over radical 3. But that's how to do the actual integral itself.